What is order and what is chaos? These are questions that are actually fundamental to chemistry, because depending on if a piece of matter is ordered or chaotic, it will also determine the state. There are three types of states that most people are familiar with: the solid, the liquid, and the gaseous. There is also a fourth state where subatomic particles like electrons start to disengage from the actual atoms: plasma. We will focus on the solid state in this video, because you may not realize it, but in every single day when you engage with the solid world, you are engaging in a world of order. You are probably familiar with crystals. Crystals can come in many different shapes depending on what type of elements it's made out of. There is, however, one type of compound that is pretty much unbeatable when it comes to order, in most cases, and that is ionic compounds. That is because of the nature of the chemical bond, that is the ionic bond. You see, unlike a covalent bond, an ionic bond is not so much of a sharing of electrons as it is taking of electrons. You have one atom that gives up its electrons to another atom that is simply better at keeping those electrons. This is the very basic model for which we understand ionic compounds. Take something as simple as table salt, sodium chloride, which has an amazingly symmetrical structure once you go down to the molecular level. If it wasn't for the nature of ionic compounds and the order that they bring, materials such as concrete and cement wouldn't be nearly as strong as they actually are. Ionic compounds are also known as salts. And whenever you look at any kind of salt in the future, I want you to marvel at the sheer level of order that exists in these compounds. Metals are also crystals in their solid form, and they can display an amazing array of order as well. However, unlike ionic compounds, there is actually a lot more movement in any kind of metal than you might be aware of. Even in the strongest metallic crystals, there is movement. Tiny microscopic fragments of this solid piece of matter, spontaneously behaving almost like a liquid and moving from one place to another. In terms of state, it's almost as if metals can't really make up their mind. In fact, a model of how metallic atoms share the electrons between each other explains beautifully a lot of the chemical and physical properties of metals. It does this by imagining the electrons existing almost as if in a sea, and the individual metallic atoms can rather be seen as positive ions, akin to islands, if you will. The flow of these electrons, as though they are a sea, explains a lot of things about metals, such as why most of them are very good at conducting heat and electricity. However, it also explains how, for a millisecond, when striking a metal with sufficient force, they behave locally almost like a liquid, enabling them to quickly change their shape, and then, almost as if nothing had happened, return to their old solid self. Metals may be crystals, but it's almost as if they're alive, which I just cannot help but to find very fascinating. However, not all types of solids are as orderly as ionic compounds. nor are they capable of temporarily acting almost like a liquid, such as metals. And yet they are solid. At least you may perceive them as such. Take yourself, for instance, and your body. If you were to take your finger and try and poke through your body, you would probably not succeed. At least I hope you wouldn't be able to penetrate, because that would be rather painful. But the resistance you feel is as if you're a solid. And in many ways you are. But the reality is that the cells you're made out of is a combination of different types of states. Specifically, the solid and the liquid. However, ultimately the reason you appear to be a fully solid object is because of the membranes of your cells. You see, there are molecules called lipids that form the membranes of your cell. The polar region of the lipid in your cell membrane is on the outside and on the inside, while the non-polar hydrophobic end is within the actual membrane itself. Within the cell you have mostly liquid, and due to the ordered nature of your cell membrane, the cell appears to be almost entirely solid. Once again, we see how order brings forth the solid state. The state that allows you to hold anything without it falling through your hands. Hell, if you weren't a solid, you wouldn't even have hands, would you? Order tends to bring solidness. I merely ask of you to ponder a bit in your everyday life as to why it is that you can differentiate between your coffee mug and your morning coffee, the balloon you're holding and the air you blow into it, or your expensive sofa and the wine you just spilled on it. So next time you ruin your expensive sofa, try not to be too angry. Just be in awe of the amazing chemistry of order and how it in turn enables you to even observe the universe as it is. Oh god, no, I just spilled coffee all over myself. God damn it. When most people think of a chemical reaction, they usually think of something along these lines. You have your simple reactants, and they form your products, and that is the end of it. But in actuality, it usually looks like this, where the capital letters represent probably aware of at this point. I am a chemistry student, but I've never really explained to any of you why I decided to study chemistry. What is it about this particular science that intrigues me? Chemistry is the study of cause and effect. What do I mean by that? Well, physics can fundamentally be broken down into the science of vectors. Time, space, and force. But chemistry can fundamentally be broken down into the science of structure. Without structure in a universe, cause and effect become meaningless terms.